Point 5, which is the variation section, the learning objectives are to construct the model using direct, inverse, and joint variation. We are going to construct the model to help us answer some specific questions. Okay. All right. So variation describes how one quantity changes in relation to another. In mathematics, we use variation models to represent real-life relationships where values increase or decrease together in a predictable way. So the three types that we have. For direct variation, let's think about as one quantity increases, the other increases at a constant rate. One example to this will be um, my, pay, earn, and hours work. So the numbers of hours you work, the more money you make. Okay. For inverse variation, as one quantity increases, the other one decreases. An example will be the time it takes to complete a job with the number of workers. The more workers means less time needed. And then we have joint variation, and this is when one quantity depends on two or more variables. An example to that will be the area of a rectangle depends on both the length and the width. All right. And we will say that the area of the rectangle, this will be your dependent variable, and the length and the width will be your independent variables. Okay, let's see. Now, here are some steps that we will take in order to create the model, and then we will, using that model, answer the questions. So first, you want to identify the variables, okay? You want to decide which is in the dependent variable, which is usually written first in the applications, okay? And then which one is in independent variable, all right? If you go back to here, pay, earn, that is your dependent variable, and hours worked is your independent variable, okay? Let's go back here. So first we're gonna identify the variables. I also recommend to highlight anything that you consider important. Also, let's say, make sure, let's say we're using X and Y. Well, what does the Y represent? What does the X represent? Then we need to decide what type of variation are you working with, direct, inverse, or joint, because the models will vary. We're gonna write what is called a skeleton model, all right? And this is just to help us identify what is the K. Okay, so we're gonna look for a K, go over that a little bit more. Then we're gonna, once we have solved for the K, then we are going to recreate our actual model. We're gonna make sure we check our units, we're gonna solve, and then make sure that your final answer does make sense within the problem. Okay. Oops. Okay, yeah, this is the next one. So in mind, have the steps. All right. So then we're going to look at the first variation, which is directly. Okay, so the idea will go, let X and Y denote two quantities. Then Y vary directly with X, or Y is directly proportional to X. If there's a non-zero number K for which, so this is this right here. Okay, let me get the drawing function going on here. Okay. So this right here, it's just going to help us create our skeleton model. So the Y is a dependent variable. The X is an independent variable. And the K is the constant of proportionality. I cannot pronounce this guy right here, this word. Okay, and when I meant we were going to solve for K, this is what we're going to solve for. And once we know the K, and in the problem, they will give us the information for us to be able to solve K. Then once we have the K value, then we can create our model. All right, we're gonna do 2 examples. Okay. Oh, I don't have that much space. Okay. So the monthly payment P on a mortgage varies directly with the amount borrowed B. Okay, so we know this says varies directly, so we already identified the type of variation that we're going to be working with. Okay, so we know that varies directly is y equals k times x. Note also here where it says, oops, monthly payment B, okay, varies directly with the amount borrowed. So the amount borrowed is your independent variable. In this case, that will be your x. And the monthly payment, which depends on the amount borrowed, will be your y. Okay, so I am using P for monthly payment and B for y. So if I take the information of y equals k x and I rewrite it using these variables, so I have P equals k b. Okay, now I need to find the k. I need to find the k. If you notice in the second sentence, they're going to give you all the information you need in order to find the k. It says if the monthly payment on a 30-year mortgage is $6.69 for every 1,000 borrowed, find a linear equation that relates to that monthly payment. So I am taking that information in. So if the payment is $6.69 for every 1,000 borrowed, what will k be? Once you do that, divide by 1,000, k, it's going to be 0.00669. Now that you have that, you know the value of k, you can go ahead and replace that. So now it's P equals 0.00669 B. Now this is the model that you're going to use to answer any question regarding the monthly payment and the amount borrowed. So in the last sentence, they ask you, find the monthly payment P when the amount borrowed is 195,000. Well, I'm simply going to find that. So I'm going to multiply 0.00669. Oop, I'm not going to have space. 195,000. Boom. Once you do that multiplication, you get 1,304.55. Traditionally, examples like this will say for you to round to the 100th place or to 2 decimal places. So we'll use that for this example. Okay, we're going to do one more example in direct variation. So we have this example here. It says the distance S, okay, that an object falls is directly proportional to the square of the time of the fall. So directly proportional. This goes back to the definition for direct variation. So we know we're doing with direct variation, so our model shall look something like this. So what we need to look is the k value. I am going to use the variables that I'm given. This is my dependent variable because it depends on the time. Okay. Notice how it says to the square of the time. That means that is t squared. Okay. T square, the square of the time. Okay. So now I am going to find my k. Okay. If the object falls 16 feet, okay. So that is if it falls, the distance. Okay. I don't know k. And time is 1 second. So this is 16, 1 square is 1 square times k is k. So the model that I'm going to be using, it's going to be S equals 16t squared. This is the model that's going to help me answer any questions. Now, my last sentence says, how far would it fall in 4 seconds and how long it would take an object to fall 400 feet. So when time is 4, what is the distance? Okay. And if I'm not mistaken, that's 200 and what? Did I not write it over here? 250 something. 256? Is it 256? Let me see. I should know this, right? 16 times 16. Yeah, 256. 256 feet, right? Because distance is in feet. So this is 4 square, 16, 16 times 16, 256. And then they would like for us to know when the distance is 400 feet, what is the time? So then if distance is 400 feet, and this is 16, not 16, what am I doing? Where is the eraser? Oh yeah, it is 16. What am I doing? I don't know. Yes, 16 t squared. We're going to divide by 16. Boom. 16 squared. That gives you a nice decimal, actually, if you simplify that fraction. No, a whole number, my bad, 25. I must be confusing the other examples. Now, you're solving for t, so we are going to do square root of this and square root of this. And then the square root cancels the square, so that's just t. And then square root of 25 is 5. And we're not going to concern ourselves with the negative because we're dealing with time, and time is the positive. So this is 5 seconds. Okay. Oops. Units are very important. Make sure we are paying attention to our units.